The next part of the presentation will focus on the supply side of the market or the economy. So we will look at the theory of the firm and what firms do in terms of production and what input combinations they will use to minimize cost, because the aim of firms is to minimize cost, whereas in the case of the consumer is to maximize total utility. So some new things that we will deal with is, for example, isoquants and isocost lines in the following two chapters. So in the previous chapters we focus on the demand side of the economy and how consumers behave. Now we're looking at how does producers behave and how will producers produce efficiently, and how their cost of production will change as the prices of input change and the level of output changes. So the theory of the firm is actually an explanation of how a firm makes cost minimizing production decisions and how the cost will vary with the output changes. So this is what we're going to look at in chapter 6 and chapter 7. And then we will look at the production decisions of firms, and there are three things that we will look at, in terms of production technology, the cost constraint that firms also face, like a consumer face a budget line or budget constraint. A firm also faces an ISO cost line, and then input choices. What will be the input choices that the firm have to make to minimize cost, because the firm wants to minimize cost in the end to maximize profit. So these are the production decisions of a firm. So you can just read through this. We know why do firms exist. You can just read through this. And then we talk about the technology of production, where there are 4 factors of production that is needed: labor, capital, entrepreneurship and materials. I'm not going to go into detail what it is. We know that from first year. But what is important is that you need to know what is a production function. Mathematically, a production function can be illustrated. Q is a function of, and we assume there are only 2 factors of production: capital and labor. So a production function shows the highest output, the maximum output that can be produced for every specified combination of inputs. So we're talking about capital and we're talking about labor as a combination of the 2 inputs. So this is what the production function looks at. So actually what it illustrates is what is technically feasible when the firm use capital and labor as efficiently as possible. What is the maximum output that can be gained by the inputs, using the inputs the most effectively, right? So just take note, because we will later come to production functions and the different types of production functions. So this is the equation that we use to describe a production function. Then very important in terms of production and theory or cost theory is the distinguish between short run and long run in production theory. Now we've dealt with that in the first year as well, so it's just a revision of it. It's not short run and long run. It doesn't relate to calendar time, how many months or how many years. It's the time that a firm will take to adjust to maybe the production process, to an increase in demand or a decrease in demand. Some firms need more time because they have to not only employ more people, but they have to build more buildings, install more machinery. So they will take longer. In the long run, they will be able to adjust. Some firms can do it, in the short run. The adjustment can take place because maybe they can only employ more people, work longer hours. So it's a question of what is the period of time in which quantities or of one or more production factors can be changed. So we're talking about labor and capital. Capital is more difficult to change in the short run because it means that you have to build buildings, install machinery. So that is more flexible in the longer run. But when you talk about labor, you can employ more labor in the short run. Okay. So in the short run, we assume, remember from the first year, that at least one input is fixed, and we assume that capital is fixed and labor is the variable input. We can employ more labor in the short run and in that way increase the output. So that is based also on the law of diminishing marginal returns, which we have done in the first year. So just revise that again. I'm not going to revise it again. So in the short run, we assume that one input is fixed and the others are variable. In the long run, all inputs are variable. You can change your capital, you can build more buildings, install more machinery, and you can employ more labor, right? So yeah, this is just the distinction between long run and short run. Now, the next section just discuss, what we have looked at in the first year, so I'm not going to revise it again. And out of this you will see labor is the variable input, capital remains fixed at 10 units, and then the total output increase, average product and marginal product, and the marginal product is actually the additional product that you get or the additional output that you get by employing an additional unit of labor. So that you can go through for your first year, and then basically, just the concepts there. Average product is the output per unit of a particular input, and then the marginal product is the additional output that you gain by increasing your labor by 1 unit all the time. Then basically, the shapes of the total product curve and the average product curve and the marginal product curve. I won't ask it again because this is first year work, but actually the shape of these curves are grounded in the law of diminishing marginal returns. You can see the shape of the total product curve give rise to the shape of the average product and the marginal product curve. So this is work from first year, so I won't test you again on it. And then the law of diminishing marginal returns. As you increase your output by 1 unit and the capital is the fixed input, the addition to output will eventually decrease. So it means that as you increase your labor by 1 unit, the marginal product of labor will decline, and that means that is what we call the law of diminishing marginal returns. Now, that is only applicable in the short run when one input is fixed. Now, I won't test you again on this because this is the short run position or the short run production function, and which is illustrated by the law of diminishing marginal returns. So, yeah, what is important is, and you can ignore all of this, is the question of production with 2 variable inputs. So we're looking at the long run where both inputs are variable. Now, then we will use certain tools that economists use to describe what will be, because what are the challenges for firms here? They need to decide what are the input combinations that will maximize output. What are the input combinations of capital and labor that will give them the maximum output, that will provide them efficient production, okay, and minimize cost of production. That is what they are aiming for. So what are the tools that economists then use to describe it is what we call isoquants and isocosts. Now in this chapter we will deal with isoquants. Now isoquants corresponds with consumer theory of indifference curves, right? And isoquants correspond to consumer theory of the budget line. So, a firm will have different isoquants, right, which shows all possible combination of inputs that will yield the same output. Now, if you relate that to indifference curves, we said that all points on indifference curves, it doesn't matter which combination you choose, will provide the same level of total utility. Now, this is the same with an isoquant. Here we're talking about inputs, capital and labor, all possible combinations that will provide the same output. So it doesn't matter if you're choosing combination A or 2 or whatever, it will provide the same output, right? So that is what we call an isoquant. And then we also get an isoquant map, like an indifference map, which shows a number of isoquants, which will then describe a certain production function. So yeah, these are a bit of new terms which you need to take note of. And then, okay, figure 6.5 just describe you production with 2 variable inputs by using a set of isoquants. or you will see an isoquant map here. Now I won't ask you to draw this diagram, but just to, because now we're on the supply side of the economy, because it's a question of input. What is a production function? It shows the highest output that can be gained or that can be produced with the specific combination of inputs of labor and capital. So you will see here, if you look at, there are three isoquants, Q1, and if you're on that isoquant, you will produce 55 units per year. And if you either at point A or D, it doesn't matter. If you are producing point A, 3, and you make use of 3 units of capital and 1 unit of labor, or you're at point D using 1 unit of capital and 3 units of labor, you will produce 55 units of the product. If you're using isoquant Q2, the total output will be 75 units per year. Now there are 2 points that is being, or 1 point actually, but there are more points, like point B. If you use 3 units of capital and 2 units of labor, it doesn't matter, it will give you 75 units of the output per year. If you're on isoquant Q3, which firms, they want to be on the highest isoquant possible, like in indifference curve further away from the origin, then they want to choose maybe isoquant Q3, which will provide them a greater output. So if they at point E or C, say for example at point C, what will be the combination of capital and labor? 3 units of capital and 3 units of labor. Okay, so that will be the combination that will be used to minimize cost, because all of these combinations is there to minimize cost. If they choose combination E, it will be 5 units of capital and 2 units of labor. So you will see what is the important point here is that this isoquant map describes a firm's production function. Okay. Now if you draw a horizontal line at a particular level of capital, say for example at 3, what happens? We get diminishing marginal returns, right? And this is being illustrated also in the diagram. We can observe diminishing marginal returns. So you read the levels of output from each isoquant. As labor is increased, every additional unit of labor generate less additional output, and that refers to the law of diminishing marginal returns, which is also applicable in the long run. Okay. So that is the purpose of drawing that horizontal line, and we say capital is fixed, and if increase labor all the time by 1 additional unit, the additional output will decline. Okay, so this is just to illustrate to you a production function with 2 variable inputs, which happens in the long run, and then we introduce the isoquant map, which is similar to an indifference curve map. Okay, now we've already mentioned there diminishing marginal returns is also applicable in the long run. So you can just look at that. Then an important term that you also need to describe in terms of the test is, remember we looked at in consumer theory, we look at the MRS, which is the marginal rate of substitution. In production and cost theory, we're talking about the MRTS. Now it's similar to the the MRS, but now we're talking from the input side of the economy, the supply side of the economy. So what is the MRTS? You need to be able for the test only to define it. I won't ask you to calculate it. So actually the MRS is the amount by which the quantity of one input can be reduced when 1 extra unit of another input is used, but under the assumption that output remains constant. So it's similar to the when the MRS, when we move from combination A to B along the curve, the exchange ratio, you decreasing 1 unit of food or clothing to get an additional 1 unit of food. But now we're talking about not the 2 products, we're talking about capital and labor. And we assume then you know the MRTS is that exchange ratio between capital, the change in capital to get an additional unit of labor, under the assumption that the total output level remains fixed, that is Q, remain fixed. So this is what we call the MRTS, and basically it's also the substitution among inputs, similar to the MRS, which is a substitution between two products, right? Food and clothing. Here we're talking about substitution between capital and labor. Okay, so this is important concepts, and also what you will see is that as you replace labor or capital with labor, what will happen with MRTS? It will diminish all the time, right? Okay, just take note of that. You don't need to use any, I won't ask you any equations, but you can see from this figure 6.6, like in difference curves, isoquants are downward sloping and is convex as well. So it's the same as in difference curves, and you know, what do we mean by the marginal rate of technical substitution? It refers to the ability of the firm to replace capital with labor while maintaining the same level of output. So I won't ask you to draw the diagram, but you need to know is that the marginal rate of technical substitution also declines as you move along the curve. So it's also downward sloping and it's convex to the origin, right? And at any point, the slope of the isoquant at any point measures what we call the MRTS, okay? Like, remember, the slope of the indifference curve is calculated by the MRS of the consumer. Now, the slope of the isoquant at any point on the isoquant is measured by the MRTS of the firm, the marginal rate of technical substitution. Okay, and what do we mean by the marginal rate of technical substitution? Is the ability of firms to replace capital with labor, and very, very important, while maintaining the same level of output. So the level of output here, as you can see, if you at Q1, Q2 or Q3 remains at 55, at 75 or at 90. The level of output doesn't change as you move along the isoquant, right? Okay. But as you move along the isoquant, what declines? The MRTS. You can see, if you look at isoquant Q2, the MRTS declines from 2 to 1, and from 2/3 to 1/3. Okay, I won't ask you to calculate it, but this is just to illustrate as we move along the isoquant, as in the indifference curve, the MRS is declining, and in the case of the isoquant, MRTS is also declining, right? Okay, so this is important, the MRTS, and you need to be able to define it, but I won't ask you to calculate it or to illustrate it by way of a graph as in figure 6.6. Figure 6.6 is important just to illustrate the principle that what is the MRTS and what happens with the slope of the MRTS, or what determines the slope of the isoquant, that is the MRTS, at any point on the isoquant, and what happens with the MRTS along the curve, and then also isoquants are downward sloping and convex to the origin. Why? Because of a declining MRTS. Now, we've dealt with production functions. We said that a production function is the function of two inputs, right? Capital and labor. Now, there are two special cases. This is the general production function. But there are two special cases of production function, and in terms of the test, you have to distinguish between the two in terms of words and graphically. So there are two extreme cases of production functions that shows the possible input substitution in the production process. And these are extreme cases which are not, it's theoretical, it's not in the real world. But we also look at the theory. So the first one is what we call the fixed proportion production function, and then also what we call the perfect substitutes. Now, perfect substitutes will have the shape of the production function will be different from the fixed proportion production function, or the fixed proportion production function is also called the Leontief production function. So just take note of this. The alternative name to a fixed production function is also called, or the fixed proportion production function is also called the Leontief production function. So these are the two production functions. Now, if you look at where inputs are perfect substitutes, then the isoquants are illustrated by straight lines. Now, what is the reasons for that? The reason for that is you can see isoquant Q1. There are three isoquants in this diagram, and you have to be able to draw it, and it's not difficult to illustrate it. So you will see, if you have to, capital is measured, the units of capital that you use per month, the units of labor that you use per month, and then you will have isoquant Q1. Then you will have isoquant Q2. Then you will have isoquant Q3. Three different isoquants. This is an isoquant map. Now, you will choose any combination, maybe A or B. It doesn't matter if you choose combination A or B or C on isoquant Q3, because it will provide you with the same output, which is maybe, in the example, 90 units. This one will be 75, and I think this one is 55, right? Now, what is important is that if the two inputs are perfect substitutes, then the MRTS remains constant as you move along the isoquant. So it means that the ratio of capital and labor, the ratio at which it can be substituted, one for it's constant. It's the same, right? It doesn't change as you move along the isoquant. So that's why the MRTS is always equal to it's constant, right? And it doesn't matter what level of input you are using, what combination you are using. Okay? So, for example, if you look at isoquant Q3, points A, B, C represent three different capital labor combination that generates the same output, 90 units, right? So this is where inputs are perfect substitutes. Then the MRTS is constant, and because of that, the MRTS is then a straight line, and you can see it in the diagram. Okay, so this is one of the extreme cases. What about when we talk about the fixed production function or the Leontief production function? How will the shape of the production function then be? If that is the case, if you draw a production function, you have capital per month, the units of capital. We're talking about the quantity of units of capital that is being used, and the number of labor units that you are using per month. And then you will see the proportion. You will see it's L-shaped. Now, you have 3 points here, A, B, and C. And then you will see the shape of this curve. Even, the proportion, let's look at point A. You use K1 units of capital, and you use L1 units of capital. That gives you this combination. Now, to draw the production function for this combination, right? This will be the production function. This will be the isoquant that will illustrate. Remember, isoquants are used to illustrate production functions. That are the purpose, right? So Q1, your isoquants will be L-shaped. It will be L-shaped when we talk about fixed proportion production function. Now, why is it L-shaped? There's only one combination of labor and capital. There's only one combination of capital and labor that can produce a given output, such as point A. So the only combination that can produce point A is K1 combination and L1 combination. Only this combination can produce output A, a given output. Okay? And point B on isoquant Q2 and point C on, so only one combination of, that's why we say it's a fixed proportion. So it means that there's a set proportion of capital and labor that can produce, A or B. B might be K2 and L2. Only that combination can produce, combination B on isoquant Q2. That means this is 55 units. This is, in terms of the example, if you go back, I think it's 75, and then C will be 90. That is, so maybe K3 and then L3. So only K3 and L3 can produce combination C, which is isoquant Q3, which is 90 units. Okay. So to summarize, to produce combination A, there's only one combination that can produce that output level, of Q1. That means K1 and L1. To produce output level B on isoquant Q2, only one combination of capital and labor can produce that. The combination is K2 and L2 is not shown in the graph, but you can add it. We only focus on the one combination, and then there's only one combination of capital and labor that can produce Q3 or point C, for example, and that is maybe K3 or K3 and L3. So it's a fixed proportion. The combination are fixed to produce a certain level of output on different isoquants, and we call this production function a Leontief production function, and it's indicated by a L-shape isoquant, which indicates that it's a fixed proportion of capital and labor that can be that only can be used to produce a certain output level. Okay, so these are the two extreme production functions, and the rest you can then ignore that practical examples. Then the last part of this chapter, which is quite important, but we also looked at it in the first year, is when we talk about returns to scale. Now, in the test, you have to be able to define these concepts. Remember, we talked about in the first year about economies of scale, diseconomies of scale. We talk about returns to scale, increasing returns to scale, decreasing, and constant returns to scale. So you have to be able to define this concept. So what is returns to scale? Because I will test you on concepts like economies of scale, which we come to in chapter 7 when we look at the long run average cost curve. But here we just need to look at returns to scale. It's actually saying the rate at which it's a question of what will happen with your output as you increase your input. So returns to scale is the rate at which your output will increase as inputs are increased proportionally. So if you increase your inputs by say 10%, that means labor and capital, what will happen with your output? Okay, so that is the returns to scale concept. Then we get three types of returns to scale: increasing returns to scale, constant returns to scale, and decreasing returns to scale. Now, if there's increasing returns to scale, and this is what firms want to be in, that position, it means that if you increase your input, maybe the input of labor and capital, say by 10%, and we've done this in the first year, then output will more than double, right? So the output might increase by 15%. So input increased by 10%, and then your output increased by 15% output. So that is increasing returns to scale, and firms want to be in that position, right? Then constant returns to scale, if you increase your input by 10%, then what will happen with your output? That's why we say constant. Then your output will also increase by 10%, the level of output. So that means as your output doubles, say increase by 10%, then basically there will be constant returns to scale. So it will be constant. The input proportion and the output proportion will be the same. Decreasing returns to scale, no firm wants to be in that position. So in reality, firms normally will experience either one of the two: increasing, which they want to be in, or decreasing returns scale, which firms don't want to be in. Constant returns to scale, that in reality it won't happen. This is theoretically. So let's look at the practical example, and this is work from first year. You can just go back to your textbook from the first year, but it's important also for the second year, because when we move to the next chapter, this concept you need to apply. So decreasing returns to scale, if you increase your output by 10%, what will happen with your output? Your output will increase, but by less than 10%, maybe by only 8%. Now that is negative, right? So it means that there is decreasing returns to scale, and no firm wants to be in that position. Okay? And you will see the diagrams. You can look at figure 6.10, which indicate figure 6.10, the A part. If there's constant returns to scale, and maybe I won't ask it in the test, but if you look at the difference between the isoquants, if they are equally spaced, as output increases proportionally, as your input increases and your output increases proportionally, then you will see the isoquants are equally spaced. You can see that 10, 20 to they are equally spaced, and if they are equally spaced, then that illustrates constant returns to scale. Now if you look at the B diagram, if they are increasing returns to scale, now I won't ask you to draw it, but maybe you must be able to identify it. When they are increasing returns to scale, you will see the isoquants are closer together as your inputs increased along the line. So these are the main difference between constant returns to scale and increasing returns to scale in terms of as your output, what happens as your input increase, what happens with your output, what is the proportional changes. And this is the difference between constant returns to scale and increase in returns to scale. So remember, most of the chapter we've dealt on the first year. You can ignore the rest. This is just some practical examples. Most of the first part of the chapter we have done in the first year. We're looking at the short run production function, where we look at where one input is fixed, that is capital, and labor is the variable input, and we looked at the law of diminishing marginal returns. We look at the relationship between the total product curve and the average product and the marginal product curve, and the shape of the curves, which is grounded in the law of diminishing marginal returns. Then we're looking at the long run, where both, and this is the more important one for the second year. In the long run, both inputs are variable, but the law of diminishing returns is also applicable in the long run, because as we apply, as output increases, there's decreasing marginal returns of labor and capital, the combination. But also the challenge of firms is to look at what input combinations will then give them the same level of output or minimize cost. And here we illustrate that by using isoquants, because the isoquant then show all possible combinations of the inputs that will give them the same level of the same level of output. So it doesn't matter if you are point A or B or C on the same output, on the same isoquant, it will give you the same level of output. And then we have the isoquant map, and if you go back to, then we looked at the Maas rate of technical substitution, which is an important concept that you need to be able to define. And then we look at production functions, the two special cases, the production function where the inputs are perfect substitutes, and then the isoquants are straight lines, because the MRTS is a constant. And then we have the where the two are fixed proportion, that is the Leontief production function, and then only one combination of labor and capital can produce a certain level of output. And then we look at the concept of returns to scale. So this covers the important areas that you need to know in terms of the test for chapter 6. Chapter 7, we will now look at cost. And we will focus firstly on the short run cost, which will, we've done that in the first year. The focus will be more on the long run cost. And we will see in the long run, firms can produce output cheaper. And we will look at why. What is the reason for that? Because of the inflexibility of short run production. And then we will introduce what we call the long run average cost curve. And then we will look at, what we call, in terms of the LAC and economies of scale and diseconomies of scale, and we look at economies of scope, all of this, and the product transformation curve. These are new concepts. And then we will also introduce the expansion path, and from the expansion path you can derive the long run average cost curve, and you use that long run average cost curve basically to determine economies of scale, constant returns to scale from last year, and diseconomies of scale. These are new things, and in the next presentation I will look at chapter 7. Thank you.